Welcome to WhiteboardDoodles, the channel where we simplify tech-related concepts using whiteboard animations. In today's video, we will be talking about computer architecture. In our digitally driven world, computers are the backbone of countless applications, from personal gadgets to large-scale enterprise systems. Understanding the fundamental parts that make up a computer is crucial for anyone interested in technology. Today, we'll explore the core components of computer architecture, breaking down the key elements that enable computers to function. So let's get started. Computer architecture can be fairly complex and comes in many variations, but almost all systems share the following components: the CPU, RAM, storage, motherboard, GPU, PSU, cooling system, and I/O devices. These are the basic building blocks of modern computers. Today, we will explore each of them and discuss their roles in the functioning of a computer. We'll start with the CPU. The CPU, or Central Processing Unit, is often referred to as the brain of the computer. It's the primary component responsible for executing instructions from both software and hardware, ensuring that your computer runs smoothly and efficiently. Imagine it as the master conductor in an orchestra, directing all the different sections to work in perfect harmony. Whether you're browsing the web, playing a game, editing a video, or running a complex program, the CPU is hard at work behind the scenes. It takes in data, processes it, performs calculations, and sends out instructions to the rest of the system. This involves tasks like fetching data from memory, decoding instructions, performing arithmetic operations, and managing input and output operations. Essentially, the CPU is the driving force that powers your computer's performance, making it an indispensable component in any computer system. Up next, we have RAM. RAM, or Random Access Memory, is the short-term memory of your computer, designed to store data that your CPU needs quick access to. Imagine it as a workspace where your computer temporarily holds information it's actively using, so it can be quickly retrieved and processed. When you open a program, load a file, or perform any task, RAM provides the space to hold this data for immediate use. This makes multitasking smooth and efficient, allowing you to switch between applications without significant delays. Unlike long-term storage like hard drives or SSDs, RAM is volatile, meaning it loses all stored information when the computer is turned off. However, its speed and efficiency are crucial for ensuring your system runs swiftly and responsively. The more RAM your computer has, the more data it can handle at once, which generally translates to better performance, especially for memory-intensive tasks like video editing, gaming, and running virtual machines. While RAM doesn't store your files permanently, its role in maintaining your computer's speed and efficiency is vital, making it a crucial part of any modern computing system. Coming up next is storage. Storage in a computer refers to the component where data is saved permanently, allowing you to store files, applications, and your operating system. Unlike RAM, storage retains information even when the computer is powered down. There are two primary types of storage: hard disk drives, HDDs, and solid-state drives, SSDs. Hard disk drives use spinning magnetic disks to read and write data, offering large capacities at a lower cost, though they tend to be slower. On the other hand, solid-state drives use flash memory, providing much faster data access speeds and improved performance, albeit usually at a higher cost. The choice between HDD and SSD often depends on your need for speed versus storage capacity. Whether you're saving documents, installing software, or booting up your system, storage plays a critical role in keeping your data safe and readily accessible. Now let's take a look at the motherboard. The motherboard is the central hub of a computer, acting as the main circuit board that connects and allows communication between all other components. It houses the CPU, RAM, storage drives, and various expansion cards, linking them together so they can function as a cohesive unit. The motherboard also includes a chipset that manages data flow between the processor, memory, and peripherals. Additionally, it provides essential connectors and slots for attaching external devices, such as USB ports, audio jacks, and network interfaces. Modern motherboards also often come with integrated features like Wi-Fi and Bluetooth, eliminating the need for additional expansion cards for these functions. In summary, the motherboard is the backbone of the computer, facilitating power distribution and communication between all components, making it a critical part of any computer system. Moving on to the GPU. The GPU, or Graphics Processing Unit, is a specialized processor designed to accelerate graphics rendering. Unlike the CPU, which handles general computing tasks, the GPU is optimized for parallel processing, making it essential for rendering images, videos, and animations. It's particularly vital for gaming, video editing, and any application that requires high-resolution graphics. Modern GPUs also play a significant role in scientific computing, machine learning, and cryptocurrency mining due to their ability to handle large amounts of data simultaneously. The GPU can be integrated into the motherboard or exist as a separate card. By offloading intensive graphical computations from the CPU, the GPU enhances overall system performance, enabling smoother visuals and more efficient processing for demanding tasks. Now, let's shift our focus to the PSU. The PSU, or power supply unit, is a crucial component of a computer that provides the necessary electrical power for all other parts to function. It converts the alternating current from your wall outlet into the direct current that the computer components need. The PSU distributes this power to the motherboard, CPU, GPU, drives, and other peripherals through various connectors and cables. Ensuring that a computer has a reliable and appropriately rated PSU is vital, as insufficient or unstable power can lead to system instability, crashes, or hardware damage. Additionally, modern PSUs come with efficiency ratings such as 80+ certification, indicating how effectively they convert power and reduce energy waste, which can be an important consideration for both performance and energy consumption. Next, let's discuss the cooling system. The cooling system in a computer is essential for maintaining optimal operating temperatures and preventing overheating of critical components. It includes various elements like fans, heat sinks, and sometimes liquid cooling solutions, all designed to dissipate heat generated by the CPU, GPU, and other hardware. Effective cooling ensures that these components run efficiently and reliably, avoiding thermal throttling, which can reduce performance or even cause hardware failure. High-performance systems, such as gaming rigs or servers, often require more advanced cooling solutions to handle the increased heat output. Regular maintenance, such as cleaning dust from fans and ensuring proper airflow within the case, is also crucial for keeping the cooling system effective and extending the lifespan of the computer. And lastly, let's take a look at I/O devices. I/O devices, or input-output devices, are essential components that enable a computer to interact with the outside world. Input devices such as keyboards, mice, and microphones allow users to provide data and commands to the computer. Output devices like monitors, printers, and speakers enable the computer to present information and feedback to the user. Some devices like touchscreens and external hard drives function as both input and output devices. These peripherals are crucial for a seamless user experience, facilitating everything from data entry and gaming to document printing and audio playback. The variety and quality of I/O devices can significantly influence how effectively and enjoyably a computer can be used, highlighting their essential role in any computer system. In conclusion, understanding the basics of computer hardware components is essential for anyone using modern technology. Knowledge of components like the CPU, RAM, storage, motherboard, GPU, PSU, cooling system, and I/O devices empowers users to make informed decisions when purchasing, upgrading, or troubleshooting their systems. It also enhances the ability to optimize performance, ensure system stability, and extend the lifespan of the computer. With technology increasingly integrated into daily life, a foundational grasp of how these components work together is invaluable for both personal and professional use. This concludes our overview of the basic hardware components. If you enjoyed it, consider subscribing to our channel and liking the video. Feel free to also check out our other videos on related topics. Thank you for watching.